This is Gail Kovac for Gresham Barlow School District. This is Summer School, High School Credit Recovery, Algebra 1B, and Learning Target number 7. I can graph a quadratic function in vertex form. Y equals h times the quantity x minus a times the quantity x minus h squared plus k. So if you saw the one that was similar to this for absolute value, there's going to be a lot of similarities there. We're going to look at the parent function or the base function. In this case, it's going to be a quadratic or just x squared. That is taking numbers and multiplying them to themselves. And we're going to see what these values of a, h, and k adjust of the function. So let's start by drawing that y equals x squared function so you know where that is. So that is x times itself. 0 times 0 is 0. 1 times 1 is 1. Negative 1 times negative 1 is positive 1. Negative 2 times negative 2 is positive 4. And this is going to start sloping upward very quickly since you're multiplying to itself here like this. Really, you can keep this going off the graph, right? And it can keep going on forever there. So there's our base level function. And this right here is the vertex. It's kind of your turnaround point, similar to the bottom for the absolute value. Very similar. So there's an a term in front. You can't see them here because they're invisible positive ones, but that's going to adjust if the parabola opens upwards like this if it's positive, or opens downwards like this if it's negative. If the a term is a larger number, if it's larger than 1, that's going to make the parabola skinnier, maybe like at 2, maybe at 4, maybe at 100. It'll be very skinny in that case. And if it is a number that is between 0 and 1, then it's going to open up really wide and flat if it's a decimal less than 1, like this. And your h and k are going to be the vertex. That's that turnaround point where your parabola starts. That's h comma k. That's this point right here. Right now at x squared, it would just be at 0, 0. So notice that this is x minus h and plus k. So if we don't see a minus or we don't see a plus, then we're going to have to adjust the function so that's what we see, because that's what this structure is looking for. All right, so let's adjust this function to match this equation right here. Let's see what we see. Our a term is an invisible positive 1, so this parabola will continue to open upward, and it'll continue to be just its base level width, that is this right here. So no adjustments yet. Now we want to find what our h and k is. I noticed that this is x plus 4 when it should have been x minus h, and this is minus 2 when it should have been plus 2, so we're going to have to make some adjustments. How did we get a positive here? Well, if you remember, subtracting a negative also gets you a positive. So really our h term is negative 4, and our a term, you can plus a negative, our k term is negative 2. So this parabola has its vertex at negative 4, negative 2. So instead of starting down here, it's going to start negative 4. It's going to start right there instead. So that was minus a negative in order to change that positive to the minus h, and there's your h, and then plus negative 2, there's your k. So it's going to look just like this, except I'm shifting it over and down instead. So the next part was to go up to 1, 1. There it is. Then after that, it's over 2 and up 3 more, or over 2 and up 4 total. 1, 2, 1, 2, 3, 4 right here. And it's going to continue going on in that fashion. And then the same thing on the other side. There's the 1, 1. There's the 2, 4 up here. Yes, there we go. And continue on in this fashion. So this is the original parent function, and this is its new child. It's a new version of it with the h and k this way. Let's try it for this one over here. And in this case, I also have an invisible plus 1. If it were a negative 1, then just remember that parabola would be flipped upside down instead. And you know what? I'm going to draw that parent function again because that really helps me to see where things should be instead. So really it's at 0, 0, it's at 1, 1, it's at 2, 4, it's at 3, 9. Oh, nice, I can keep going. 3, 9. See how that starts stretching out wide like this. 1, 2, 4, 3, 9. There it goes. So that's the original, but now we're adjusting it for this one. So it's still going to open upward in the same width because you're going to get that +1, which is invisible. Now I got to figure out the HK. Oh man, this one's easier. It's already a minus. So here's your H. And then your K, yay, that's already a positive. That's a 4. So there's your K. So the vertex is going to start instead at 2, 4. So instead of being down here, it's going to be at 1, 2, 1, 2, 3, 4. It's going to be right there instead. So imagine taking this yellow shape and just moving it over here instead. So I'll try and draw it similarly. Here's 1, 1. Here's 2, 4 up here. And that's going to keep going. All right, here's 1, 1. 2, 4 is up here. And now we're kind of a little bit off the grid that we're not going to see those upper values like we did when it was scooted down more. So this will look like this instead. So you're looking for the A, which is the multiplier, which tells you positive up or negative down, and you're not going to have to adjust the width on these particular problems. We simplified it for you a little bit, but you are going to have to figure out where that new vertex goes. Remember, it should be x minus h and squared plus k. You're gonna have to make sure those signs are the way they are, otherwise you might have to do a little bit of adjustments like you did on this one.